at the top of the hour here. So welcome everyone. Thank you so much for joining as we were on our wildfire tangent here, but relevant nonetheless. Yeah, welcome to the Passive House Accelerator Next Gen program. Today, we don't have Carmel on camera. She's not feeling so well, so you'll have to do with just me. But I'll try to bring the energy. So we also have a wonderful guest today. Our speaker is Haggerty Wilson. She's a Philadelphia-based architect and passive house consultant at Onion Flats Architecture. And since joining Onion Flats in 2017, her experience at the firm has shifted from the architect as developer and builder model to a renewed focus on designing and consulting on client-based high-performance projects with a specific interest in deep energy retrofits along the East Coast and beyond. So without further ado, I think, Kara, please go ahead and share your slides and go for it.
Awesome, thank you. Just pull this up. So as you said, my name is Kara Haggerty Wilson. I'm an architect at Onion Flats. We're based out of Philadelphia. Many people probably know us for the projects that we have developed and built. A partner at our firm, Tim McDonald, has presented on this building I'm going to talk about probably hundreds of times. So forgive me for some images you may already be familiar with, but we as a firm are kind of pivoting. We no longer are developing and building for ourselves. We're now working truly as architects and consultants, and also kind of pivoting towards the retrofit side. So that's a whole different story, maybe for another day. But this project that I'm going to speak about today is called Front Flats. And on the image on your screen now, it's the building on the left. And this is kind of the very last in-house Onion Flats development and construction project that we produced. This is located in Philadelphia, and our offices are actually in the ground floor of this building. And I like this picture because it shows our neoclassical neighbor immediately adjacent to the site there, an old bank building. But I'm going to be talking about minimizing, maximizing, or balancing, and how the kind of like tenets of a net zero design in an urban setting, when and where you do those three things. But also, I think what's going to be really clear, and I think for anyone who is in high performance design, I'm gonna like pull apart these major tenets, but it's going to be so clear how interrelated everything is. The push and pull is just everywhere, and I think that's one of the best parts about high performance design is that kind of intricate relationship between things. So a little bit of context. The site is nearly an oblong. It's 63 wide on the east-west by 110 north-south. So we have the opportunity for really great solar exposure, even in an urban setting, which is unique. It's at the nexus of 3, maybe even 4 neighborhoods, depending on who you ask. So there's a ton of stuff going on right here at this location, this intersection. Even these 2 photos are maybe 2 years old. There's new buildings everywhere that you would see if we reshot these drone photos. But so the building itself is, as you see, this kind of PV clad structure, and it actually entails this 1-story piece here, which our offices are on the ground floor here, and then this terraced exterior courtyard on the south. So this is a big south face here. The really cool thing about this project is that our southerly neighbors are, they're going through a gut renovation now, but they are not building up. So they're staying low. It's like a hospitality restaurant. So we have the benefit, even in an urban setting, of being able to take advantage of our solar exposure in ways that might be pretty unique. And then, typical urban infill pocketed by new or existing construction. The site was underutilized for so many years. It was always kind of second fiddle to the bank buildings next door, basically just used for surface parking. So anything we built here was going to be an improvement in this context. And then from a zoning perspective, because we are also the developers, we were looking at a max 25 dwelling units we were permitted and a 55-foot building height. And we actually needed to hit 55 in order to keep our units small. It was like a weird kind of balancing act within the zoning code itself. So that actually made things a little trickier for us too. And then, of course, the other thing I want to point out is the mass transit. So the Philadelphia's subway line is elevated in this portion of the city, and it runs directly in front of this building. Comes up to just about where the top of the second floor is. And so just still like with our developer hats on as we're maxing out our zoning, 25 units permitted by right. We actually went in and asked for 3 more units as a compromise for reducing commercial space at the rear, which was an alley, but was still required. So we were able to kind of negotiate that, get 3 more units for a total of 28, build out to every square foot possible of the footprint permitted, and start to kind of shape our building to really take advantage of our solar exposure on the south. I should say, and you'll see the next slide, this building kind of immediately followed the construction of another building that we developed in a different neighborhood, which we had a full solar array, really great envelope, still a pretty dense building, but did not approach net zero. I think the EUI was more like a 10 after solar, which is still awesome. But so when we started with front flats, thinking about it, the goal was always, what will it take to get to zero? What does an urban infill project, multifamily, what does it look like when it's net zero? What do we have to do? So from go, there was always this acknowledgement that the solar is going to be growing all over this building. It's got to be more than the roof footprint. So even from the early stages, even from the zoning stages, we're thinking about how do we integrate the vertical solar into our permitting, our zoning, and even just our site planning in general became really, really critical. The other part I should say, which is also just like for us as developers and as contractors, what we were comfortable with was a 4-story building and all wood, all framed. We wanted to avoid podiums. So as our comfort level is kind of capped at 4, all wood, we were starting to kind of see the zoning take shape and seeing how dense these 28 units that made our pro forma work, how they fit in this neat little simple box, and what that could potentially mean for our performance requirements for the building. So this was all this kind of balance of kit parts of things we want for our pro forma to make it work, the simplicity that we want to work from an energy perspective, working with zoning, and then also understanding that this is an experiment to get to zero. So all kind of in play all the time. Every decision is what it felt like. So like a little more context, that previous project, Capital 2, sometimes we call it the Battery, a pretty dense building still, 4 stories with a full solar array. We use the Build Smart prefabricated wall panels on Capital 2, and we're really happy with them. So we took that as our baseline and said, we're going to use it on front flats as well. It just made a ton of sense for these infill projects, as far as just for us as a small firm and small contractor too, it was really great to outsource kind of the heavy lifting in that way. And also just the constructability, the amount of time saved putting it together is another huge plus for us in these infill situations. But we started with the Capital 2 baseline wall that had 3.5 inches continuous. It turns out, just comparing the ICFA per occupant kind of like relative density, 316 ICFA per occupant at Capital 2, which was mostly 1 beds with a smattering of 2 beds. And then at front, we actually have less square footage, more dwelling units that we need. We have to have them to make the pro forma work. and it just in general, much denser grouping of units. So we have only 1 beds and then a handful of studios as well. So ICFA per occupant at front flats came to 278, which is a 12% increase in density. And so right off the bat, we said, we still want to use a Build Smart panel, but we need to acknowledge that the same wall system, the same CI layer is just not going to work for us. With that increase in density, when we're doing our energy modeling, it's just an immediate increase in those internal loads that you really can't get rid of. You have to manage in other ways. So the first step is really getting into the nuts and bolts of the envelope and seeing in which ways you can push it in order to respond to those internal loads that come with your density and come with, building in an infill site in an urban setting, especially in a very transit-oriented location as well. So what I'm showing here is like an elevation showing the wall panels. And then a couple photos of the actual like erection of the panels. So the panels were Build Smart. They come on site with windows and doors pre-installed. And in our case, we actually had the furring strips installed as well, which was also really big for us, saved us a lot of time. And I will say, I'll come back to this a little bit later when we talk about the solar shroud. But one of the awesome things about the panelization was having those shop drawings and having the like digital information and confirmation of every single stud in this building. We knew exactly where it was. And we knew that while it was still being erected. So the solar for this project was a project unto itself. And we were working on it separately and distinctly, but like coinciding with the construction. And it was so pivotal to understand and have that data available while the building was going up. So another, for us, a really great plus for having like some level of off-site panelization, even in new construction, was great. Part of the balance that came with the envelope here, again, was like, for instance, our windows. So going back to Capital 2, a dense building, but still less dense than what we're trying to achieve now. We had triple pane windows. I think they were clear wall, and the solar heat gain coefficient was probably a little higher than it needed to be. That would be a thing I think we would change if we did Cap 2 again. So when we got to front, we said, well, we're not going to use the same windows. We need a really pretty low solar heat gain coefficient, but maybe, and that costs money, additional coating, it's going to add costs. So we looked at going from a triple to a double pane window, still a really good window, but maybe taking a little bit of a hit on the U value of the overall window assembly and using some of the cost savings of doing that to be able to afford those lower solar heat gain coefficients that we really do need for this energy model to work and for this building to work. So again, like a little bit of push and pull, a little bit of investigation into different window types and what's available to you. But for this project, for instance, we ultimately went with an Alpine fiberglass double pane window. And then again, just the same conversation, already kind of mentioned it, but like tweaking that CI layer, understanding that even though these buildings, their footprint was relatively the same, there's no such thing as like a cookie cutter building, the orientation's different, there's a few more units here. It really adds up. And so tweaking to the project needs became this really critical analysis that we were constantly reviewing. System. So like they always say like address the envelope, right size the systems, add the PV. So that's kind of like the pattern I'm going to be taking here in this presentation. So step 2 is like shrink the systems. Now, Onion Flats, every single project we approach everything's on the table as far as systems go. We don't ever go right in and say, oh, it needs to be decentralized, it needs to be centralized, semi, whatever. But so again, with Front Flats, coming right off the heels of our last construction project prior, Capital 2 was a semi-centralized ERV. There were just 2 zones for the whole building. And then they had a fully centralized like VRF with heat recovery for heating and cooling. They had geothermal there too. So that was the reason for that. A lot of issues, like technical issues after construction with that system. So at Front Flats, we said, we have these really small units. We think that opens us up to maybe more products. Let's look at a Minutair. The really great thing about Minutair is that it's just one set of ductwork and there's no rooftop equipment. You don't need to hang anything off the side of the building. It really, for all of the things and goals we were trying to accomplish with this building, Minutair really fit really well for this building in particular. So Minutair, you're going to see in the top left image here is just before the actual like casework and closet is constructed, but you know, soon after installation of the actual unit, like that is the whole heating, cooling, ventilation, and dehumidification for each apartment. And like a really basic diagram on the right-hand side here, where you can just see super low impact to these already small units, which is key. But then also the ability to kind of like integrate it into casework, which we really loved. And obviously that getting stuff off the roof became really critical for us because we used our whole roof for solar and a green roof. The other kind of like innovative, at least at the time, was instead of doing like a fully centralized hot water system, what we did was we paired hot water heaters in our basement, which is mostly storage space and mechanical space. So we weren't in our heat pump hot water heaters. We weren't so concerned about the cool air being ejected from the heat pump hot water heaters because of where they were located. We paired them, and then instead of doing like one big recirc loop, we did 4 small vertical recirc loops with this Viegas Smart Loop system, which is like a concentric pipe and pipe. So you have your copper hot water supply lines, and then the pipe within the pipe is the PVC recirc pipe. So you're cutting down on your insulation. And we actually did like the calculations of how long would this recirc line be if we did a more typical, you know, big horizontal loop through the building versus these 4 smaller vertical loops. And it was a significant like savings in overall pipe length as well. So this was actually really, and we added this kind of late to the game too. We were fully designed a different way and made this change, but it did have a really big impact on just the constructability of everything too as well. It really streamlined and it's super efficient. So of course, like the less recirc you have, the less heat loss to the building you have in a really dense building where it's internal load dominated, you can't get rid of it. You just want to reduce all the other things that could potentially be adding to that heat load. So this was actually a really great move for this project as well. And then the last thing is this. So like, again, as I said before, this project was always about what will it take to get to zero for a dense building in the city. So solar was always from go part of the project. And like I mentioned before, it was its own project. It was an effort, a huge effort to design, coordinate all the parts and pieces. But so we're maximizing solar. We learned from our previous project, the roof is not enough. It's just not enough. Even if we overhang and do all sorts of things, it's not enough. We have to go vertical within the confines of our footprint, what we're allowed. And so what we did was, and truly the other part of the solar veil or shroud, whatever we want to call it, is we needed a ton of shading just because of our internal load dominant building and a cooling load dominant building. So the solar doubled as shading. It doubles as privacy to an extent. And then of course it has the generation. So we saw this as like a really beneficial to the building in more than just generating energy perspective. So once we had decided this is the route we're going all the way, we needed to figure out how to attach this thing to the building. And this is where kind of the panelization and the prefabrication was really, really crucial. we knew where every single stud in the building was. We could design these, we did design these aluminum brackets all along the building. They were designed so that we could like prefabricate the bolt holes. We knew where the studs were. Everything could be fabricated offsite. We tried to have as few variations of this as physically possible to keep it as simple as possible, even though overall the solar was not simple, but we tried to simplify it. And I should say the fabricator who built all this aluminum, Philly Metalworks, he was a member of our team. It was like his side job. So after this project, he actually went to his full-time job now is metalworking. So this was like a really cool project for him as well. But yeah, so what does it take to get to zero with all of those things considered and all the kind of like the intricate play between systems and cost, and but at the same time, like making the pro forma work, fitting within the zoning, maximizing unit counts, but really wanting to push the envelope, so to speak. We ended up at 174 kilowatt array, all sides included. Our EUI pre-solar was about a 22, 23-ish. Post-solar, we did get to net positive, but with one consideration is that there is a commercial space in this building. It is now our offices, but when we built this building, it was not intended to be our offices. So we were doing all the energy modeling and it was totally excluded. So now that we have real kind of data with our office in there, the EUI, including the commercial space, is about a 0.5. So not quite net zero, but really, really, really close. I mean, it's a project we're really proud of. It was a really complicated project, and it was in many ways an experiment with systems. You know, the Viega smart loop we had never used. We had never done the vertical cladding on the PV. We had never used the Minutair, and we bought 28 of them, and it all, you know, for all intents and purposes, it worked out really well. But I think as a case study and like it was a question that I think Tim needed to answer was what do we have to do to get one of our projects to zero? What does it look like? We have to show people. And so this Front Flats is our response to that after our deep dive. And I'll end with just a photograph of our courtyard area, which kind of looks into our offices are in the double height space there, right in front.
Gorgeous. Thank you so much.
Yeah.
This was full of really interesting details. And I think one detail everyone also enjoyed is the diagram with the very lively tenants. It got the message across very well for why you might want the privacy and why that facade was really interesting and helpful. There are lots of good questions, I think specifically about the PV and all of that. But first, we're going to kick it over to Kim for a thank you to our sponsors, and then we will get started with all of the questions and keep them coming. We'll keep going for a while.
Hi, I'd like to give a big thank you to the fine organizations that make our work at Passive House Accelerator possible. First, a big shout out to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. And thank you to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And thank you to our patron sponsors, Brennan, Coltraco Ultrasonics, Euroline Windows, Holstrom System, Inotech Windows and Doors, Lamelux, Owens Corning, RDH Building Science, Sanderson Sustainable Design, and US Engineered Wood T-Stud. Thank you, sponsors.
Thank you. All right. We have not yet said what the question queue is, so be on your toes, but we'll get that started up. Thank you, Carmel. So we have so many questions, and I have questions of my own, but I'm going to hold off for a moment. We're going to give all of the participants a chance to ask your questions. So we're going to start off with Noah Ramers. Noah, do you want to unmute and ask your question? If you cannot unmute and ask your question, I can go ahead and ask it for you. All right, I'm going to take that cue to do that. So Noah says, curious about the decision to use PV panels on the exterior instead of building integrated PV or transparent solar, ? So maybe just elaborate on that if you can.
Yeah, I think the big part was that we needed a ton of shading too. So the solar really acted as a giant shading device. If we didn't do solar, we would have had we would have had probably a very similar amount of items projecting from the building for shading purposes, regardless.
Great, thanks. And I'm curious, how did that, when you're actually in the building and experiencing it, do you get the right effect with the shading, but also having some light coming through, and how does that all work in your experience?
Yeah, I had a photo in there and I took it out, but there are openings in the PV kind of grid that align with the windows, but they do kind of intersect top and bottom. And it's kind of cool. It frames your view. And the main view is towards Center City, Philadelphia, and like towards the bridge over the river. So it's kind of an interesting, like framed perspective that they give you.
Great. That's exciting. All right, next up we have Philip Jordan, who I believe is no longer on. But I think the main question was, did you pursue Passive House certification along with this? I mean, clearly you were doing a net zero approach, but as far as Passive House certification, can you speak to that a bit?
Yeah, so we were FIAS pre-certified, Source Zero pre-certified. We ran into a little a resilient channel snafu with Energy Star. And that kind of put a little bit of a hold on how hard we were going to go for full certification. It was like a fire rating versus Energy Star type of scenario. So we did go through and do all the testing and everything, but we were ultimately not going to be certified.
Interesting. For anyone who doesn't quite understand that terminology quite as much, can you elaborate a bit on what that means? What was holding you back?
Yeah, so Energy Star is going to require, they're going to call like your drywall, your interior air barrier, even if you have like a real, what we would call the air barrier in the middle of our exterior assembly. And what they will call their interior air barrier needs to be in full and direct contact with fluffy insulation, if there is some. And we had a resilient hat channel for a fire rating purpose in our roof assembly, which meant that we were not in full contact. And so that was like a stopping point, unfortunately, but also a lesson learned to find other ways to get fire ratings, I suppose. So not necessarily a FIAS thing, but more of the FIAS prerequisite, which is meeting Energy Star.
That's so interesting.
Yeah.
Okay. And it sounds like Ron Celentano is here, so he can also help speak to the PV design here needed.
Yes, Ron was our PV guru.
Wonderful. All right, so moving on to more PV questions, we have Andrew Peel. Would you like to unmute?
Yeah, great. Kara, great job. I love what Onion Flats does, the innovative work. Curious about a cost differential between like the installed cost of PV cladding versus a cladding you would traditionally spec. And I don't really like the one line by line comparison. So maybe I can caveat my question. You mentioned about shading you'd have to have added, if not. So I don't know if you can take that on board, but if you can say anything to the cost side of things.
I can't speak specifically to the cost because the building is, I mean, it has a full cladding behind it still. So it is like a double approach. I wouldn't be able to speak to the cost specifically in that regard.
Okay, you know what? I missed that there was still traditional cladding behind that. I thought you were actually replacing it. I guess you can't. I guess the PV panels you're using, they can't be used as cladding then.
No, they're bifacial panels, so it's just like glass both sides, basically, like very kind of delicate panel, and they're held off 1.5 to 2 feet, depending on which side of the building you're on. So yeah, there's a whole traditional cladding, like weather resistant barrier, all that stuff, totally separate. And then if you think of the PVs more of just like on an outrigger system, it's a totally separate. The building could exist without the PVs, and they just kind of coexist.
Gotcha. Okay, great. Thanks.
And how did it work with the prefabrication and the attachments for PV and mitigating thermal bridging?
Yeah, I mean, we accounted for every single bolt that went in. So that was kind of the other good thing about having the wall panels and understanding exactly where everything was, feeling really confident we were going to hit structure when we needed to, and then coming back and accounting for it in our energy model was definitely a something we needed to do, and we did do. Yeah.
Diligent. All right. Next up, we have Houston Eubank. You can go ahead and unmute yourself and ask your question.
Yes, hi, thanks. Fabulous project and presentation. I especially like your hot water research solution. That's brilliant. But I'm curious about the photovoltaics on the roof. I understand that you keep them off of the roof to shade the roof, but I'm wondering if there were any special issues you ran into doing that. I noticed looks like a steel or aluminum frame underneath them to hold them up. And I'm thinking about what opportunities that gave you besides the shading.
Yeah, so they are raised above the roof, maybe 10 feet or so. And it's I think it's a glulam or I think it's a glulam system, and it's all wrapped and covered, obviously. And then the aluminum is the solar substructure. So part of the project was in Philadelphia, we have really stringent stormwater management requirements. And on an urban site, it's really tricky to do without like burying something underground. We prefer to handle it with a green roof. And we have a green roof company in-house too. So we're going to do a green roof no matter what. The issue then becomes, you want all this solar, we had to raise it. And then there's kind of like an intricate engineering analysis of making sure the green roof is getting enough sunlight and water too, in the correct patterns to survive. So once we figure that out and get the green light on that kind of is really the whole reason why the solar is totally raised up so high. There's the residual, like you can have a patio up there and have some outdoor space, which is great, but it also is a function of meeting stormwater management requirements. And being tall enough that green roof can actually function.
Cool. All right. Well, next we have Armen, who has asked that we read their question. So the question is, can you show or describe the wall assembly abutting the neighboring building and property line? Maybe just describe it.
Yeah. It was also a Build Smart panel. It was a 1 hour bearing panel that we worked with Build Smart to get to be 1 hour bearing and to meet code in that way. And then the gap was filled with insulation. The building adjacent, I don't know how thick that wall is, but it could be like 2 feet thick, and it's all brick, I would assume, brick and stone or something like that. So we kind of, and I forget where the property line was, if it may have been through that existing building. I'm sure it's through the line. We kind of set our foundations, and what was left over was not like a consistent space, I'll say. So the existing adjacent building is old and has some variation to it. So we set our wall panels, and then the rest was filled with insulation.
All right. And, you know, I think this was Carmel's question, which is a good question. You know, how does, if there are neighboring buildings that are built after this, how does that affect the production of that vertical PV that you have on the building?
Yeah, I mean, the good thing is the adjacent site south, like I said, they're just wrapping up their gut renovation, and they're not growing vertically. I mean, we're already kind of in contention with the elevated train line, which isn't going anywhere. So I think if, like, worst case scenario would be if that south site was demolished and rebuilt as like a 5-story building. That would be our worst case scenario, in which we'd have to really look at our performance year to year to see what kind of hit we'd take. We haven't gone and like done that theoretical study.
Yeah, it's interesting, but you looked at the site and were able to plan around what was there, which is not necessarily something you'd be able to do at a different site. So it was a good forethought to have that site in particular. Next we have up Tapani Tallow. Do you want to unmute yourself and ask your question? If not, I can ask it for you. All right. The question was, would the higher grade windows make you fully passive? I think maybe this was answered in the question about did you pursue passive house, but maybe amending the question to would higher grade windows contribute to higher performance?
In this case, no. No, we really tried to balance, and we started with the higher, triple pane, what's more typical, and we backed off because it wasn't making sense with the internal loads we were battling.
Yep, all about the balancing, which is your
Yep.
title here. Next we have Shannon Pendleton. Would you like to ask your question?
Thanks, Zoe and Kara. Amazing presentation. Very cool. Hi, Ron. I think this might be partially for you, but I'm wondering how you're reporting and sharing the energy modeling, and if you're sharing it with the city, and also if you're comparing it to any feasibility study you might have done.
Is that for me?
I think so.
It's available. It's not, I guess and there's no reason for it not to be shared. We use the e-gauge monitoring system, as you're familiar with, Shannon. We do share some of the information with the city because this project did get some subsidy or an incentive for the project. So they do request annual performance information. But the monitoring, I guess, isn't so knowingly available. It can be.
Thanks. Did you compare it later to a feasibility study on how much energy you modeled, in WFI or whatever you used to model it, and then the actual, so modeled versus measured? Sorry for the follow-up. Didn't mean to jump the line.
I have done some of that analysis. There have been a couple technical issues with the inverters, which have been a little problematic. So we have fallen short a little bit as compared to what we expect for its performance. But other than that, that's about as far. And I'm just really using the simple PV watts. I'm not sure if it was done as well in the in other models.
Thanks.
All right, thank you. Next up, we have Keith Green. Go ahead and unmute yourself.
Hey.
If you can.
I
There you
did.
go.
Great presentation, thanks, and great building. I'm curious, given some of the other examples that we know of reflective buildings and their effect on adjacent properties and streets and sidewalks because of the heat reflection, did you have any concerns about the adjacent properties? And if you did, who was concerned, and did you have to change the design or your specs for the PVs at all to address the concerns?
We didn't have any immediate concerns. The PV starts at basically level 2. There's like a canopy that kind of receives it at the bottom and goes up through level 4 and up to the roof. So call it level 5. And then we have the train kind of right in front of us is like the prominent feature contextually. The bank buildings adjacent also super prominent and, just as tall as us. So we would have no impact on them. To the south of us, the building stock really kind of gets shorter, down to like maybe 2 stories. And then to the rear of us is kind of like rear parking for, again, like residential single family 2-story homes. So there wasn't like in the immediate context any real need, or we thought at least for seeing that as an issue. So we didn't actually make any design changes based off of that.
Great. Next up, we have Dale. Would you like to ask your question?
Certainly the train going by. How does the people who live in there find that? What did you do and how does it work with all the great energy savings we have, but living with the train next to you just does not sound attractive.
So I will say there's a ton of new development along this train line. And I know other developments they're going to triple pane, even if they're not high performance buildings, they're switching to triple pane just for the acoustics alone. But what they're not doing is they're not airtight buildings. So we, as an airtight building, it makes all the difference, even with a double pane, more traditional window. So you hear it, but it's not what you would expect when you find out that you have a train like 10 feet from your apartment window. It's the airtightness, I think, is everything in that case.
Measure the decibels?
I don't think that we've measured it. I haven't.
We just had this incident in San Francisco. My daughter's hearing's better, so I got the better bedroom in an Airbnb, which was next to the freeway, which they didn't publicize. When you market these, I'm wondering, would the triple pane have made a significant difference, or just how you install the windows in your prefabricated walls?
I think both could have made a difference. Yeah, I think the airtightness, and then in addition, if you're obviously a triple pane is going to help, but if you install a triple pane in a building that's not airtight, I'm not sure if it would have the same effect as doing both.
I think it does in the one I installed down the street with, but that is really the reason for triple pane, is it just gives you a little better. Plus, how we install the window in the frame is really critical, and we don't always cover that very thoroughly. So, okay, well, I hope the people who live on that side are happy or have hearing like mine.
I just want to add that there's a station stop very close to that location, so the trains aren't moving very fast there. They're stopping and picking up.
They're slowing down, so you have that benefit. Good thing to put in the design thinking.
I think we have a quick follow-up question on that from Kevin Brennan. Would you like to unmute yourself? If not, I will go ahead and ask you a very quick question. What were the air tightness test results? What were the blower door numbers?
I see Tim's on the call. He might have that in his brain because I don't know if he's able to contribute in that way.
Oh, sorry. I do 0.79 ACH 50. That's another reason why I mean, aside from not meeting Energy Star because of that one issue with the roof, we just missed the 0.6 ACH 50. And the modeled, I'm somebody, whoever, I think it was Shannon, I'm pulling up the modeled versus actual consumption right now. I'll put that in the chat.
All right, thanks. Next is Brian Hicks.
Hi, can you hear me?
Yes.
Great project, Kara. Very beautiful, exciting to see. My question really concerns sort of design delivery, project delivery. So looking back, what were the major unknowns or project risks that affected your design delivery and you might have done differently as an endeavor, now looking back upon completion?
I don't know that I can answer that. I wasn't involved so much in that part of the project or that aspect of the project. I really was in the design and through construction, and we were already kind of like building off of what we had just learned on the previous project. So we were already like inherently taking a step in the right direction, it seemed, where maybe there were missteps in the past. But also still using in many ways like very similar kit of parts. So it did kind of feel like from one project to the other was just like an evolution in progress there.
So then one way to answer that is then you're leveraging past projects and past best practices to sort of minimize your project risk in a sense, right? So you're just, like you just said, you're evolving the model as you go forward.
Yep.
Great.
All right, Shannon's got another good question. Please go ahead.
Yeah, and thanks, Tim, for doing the model consumption in the background versus the measured. I'm wondering, Kara, did you guys notice a difference during the recent smoke event? I know Philly beat out New York at a certain point in having the worst air in the world for a few minutes, and go Philly. But did you guys measure or notice when you went into other buildings versus your building? Or did you check out the filters when the event seemed to come to an end to check out if they were super clogged or anything like that?
I personally was not in the office any of those days. I stayed home. So I am not sure. I can't speak personally what the difference was. And I'm not sure that, like Tim, you might not even know. This was so recent. If anything had to be done kind of unit to unit wise.
Yeah, I don't know. But what I will say is, and I think I've mentioned this before, when we finished this project in 2020, it was just before COVID hit, and we had gotten it half full, and then COVID shut everything down. We couldn't show the units anymore for about 3 or 4 months. And in the middle of COVID, it was also, if you remember correctly, there were a lot of forest fires in California at the time. And my brother came up with the idea about 3 months after we were shut down of putting a video out online about the ventilation system within the building. And he put this really cheesy but wonderful little video out talking about how amazing the air quality is. And we put it out to market again, and we rented the rest out within like 2 weeks. And many of the people that came were moving from California. And it was precisely because of the air quality issues. So it is too early. I haven't checked with our property management team about how that affected the filters, but I've been in touch with them over the past couple of weeks, and they were replacing filters anyway. But it would be interesting to find out just what they look like.
Thanks.
Yeah, I'd be interested to hear from any folks who are kind of operating passive houses or ones with high performance ventilation systems, what those ventilation systems look like after fires, and how to make sure you're replacing things properly and making sure that maintenance personnel knows to do that. So Carmel had a question on that. So what is the maintenance like on the unitized Minutair units, and how are the tenants liking them?
Yeah, so I think there's two different filters in the Minutairs that need to be replaced. And so it is definitely like a cost for the owner to keep up on that. As far as I know, there's no complaints on the Minutairs themselves. I mean, the tenants, like, all they have is kind of their wall control station, so they have no access to the unit itself. So as far as they're concerned, could be anything, and all it does is it gives them heating, cooling, and fresh air, and turns on when they're in the shower. So I believe all things are good on the Minutair front once you kind of understand as an operator all the filter replacement kind of schedules, getting on the schedule, getting them ordered beforehand, and storing them appropriately.
Okay. Well, I'm going to take advantage of the fact that the questions are not pouring in as much to ask my own questions. I'm super curious about this DHW system. Can you first describe how you decided to go kind of like semi-central with it, and who's paying the utilities for hot water here? And then I'll ask, I guess, another question on the system itself.
Yeah, so we were designed with a like a sand and hot water system pretty much through CDs, and they were all going to live like on the 4th floor in a larger closet, and then they were going to have outdoor units on the roof. And I think cost became an issue there, but also we were running into like distance between the indoor and the outdoor unit, and we were stretching it thin, like design wise. And so Tim came up with the idea to explore this Viega pipe and pipe scenario, and it's been something that now that we've used it and we've kind of proven it as a concept, or anytime we feel like it's a good fit, we try to get it into our projects, because it makes sense for a lot of reasons. And then I forget, what was your second question? Or you didn't say it yet.
I wanted to give you one at a time.
Yeah.
But the second question is, how much insulation did you end up putting on those pipes? And is there any like further design accommodation required for, you have a pipe inside a pipe, so things get thicker, and how do you handle that?
Yeah, I mean, I think the savings is that you're just insulating one pipe instead of two. And so I wouldn't say it was like any extra insulation necessarily than what we would have typically installed.
Yeah, I think
I don't have that number on the top of my head.
I think it was an R6 insulation, around 1.25 inch supply pipe. And Kara, just so you know, I didn't come up with anything. The hot water guru of North America did. Mr. Klein. I'm sure you all know him. Gary Klein.
Perfect. Thank you. And Carmel reminded me that my other question was who's paying for the hot water and did you have to
Oh.
sub-meter?
Yeah, so this building and like our other buildings that we've built, the utilities are included in the rent. So there is no kind of like sub-metering for hot water in that case.
Although there is a monitoring of hot water, and we break that, and there's monitoring of all the energy that's being used by each apartment. And Ron Salentano put together this amazing web-based monitoring system that we get to go in and look at the individual consumption per unit each month, because while it's included in their rent, their leases say there's a fixed kind of bank account of energy that they're allowed to consume within that rent. If they go over that, then they have to pay more, but nobody's done so yet.
That's an interesting approach. So with 1 minute left before maybe some folks have to leave, we'd like to ask our classic next gen question, which is, what do you feel is the future of Passive House?
Yeah, so I think I watched the Massive Passive video yesterday, and I think that is like a prime example of what is the future of Passive House, is this retrofit, this how do we deal with all of these buildings, and all of the variety of ways you could go about it. And that was like a really great example of one of them. So I think deep energy retrofits are definitely where we all need to be putting our heads.
Totally agree. All right. Well, for anyone who needs to leave, thank you so much for joining us. And we hope you'll join us next month as well, before there's a break in August. So we will have a program in July and hope to see you there. Let's see, I think we have 1 or 2 more questions. So we'll do a little bit of an after hour here, and then let everybody go. So let's see, I think Steve had a question, and maybe this is a question for Tim or others, but Steve, go ahead and ask your question.
Yeah, I was just interested what the budget was you had for the tenants, what their monthly allowance was for utilities.
I think it was about $60, I believe. I don't know if that's changed as things have changed kind of in the last couple years, rate-wise, but I believe it was about $60 per month.
Have you had situations where tenants like will bring in a space heater or some other kind of
No
appliance?
I mean, no, not to my knowledge.
I assume everything's electric, the stoves and stuff.
Everything is all electric. That's right. Yep.
All right, that might be our last question. I could probably ask about a million more, because this is full of just really interesting details and some kind of new pioneering things. So this is exactly what we like to see on here, is kind of these new ideas being proven out. But I think, let's see, I think that is it for now. So we can let you go. Just thank you so much again. Thank you for to Ron and others who joined as well, helping to answer questions. We really appreciate it. And yeah, interesting to see this new project come to life, and looking forward to seeing more and maybe some updates in the future. So thank you, everybody.